Okay, today we're going to take a look at the merge sort challenge posted by Topcoder. I've built out the merge sort coding, and I'm going to go ahead and run the test in a moment, and then we'll talk about how the merge sort is supposed to be working. So let's go ahead and run the test. And as you can see, it runs the 7 tests, comes back with 0 failures. All right, so let's go ahead and see how this merge sort works. Okay, so merge sort takes in a collection of comparables. In this example, it's going to be an array of numbers. Then this print statement here is going to show us what that array looks like. Then it's going to, if there is only one item in the array, it will return that array. However, if there are more than one item in the array, it's going to divide the array by setting a midpoint, and the midpoint is just the size of that array, and it's going to divide that size by 2, and that is the midpoint of that array. Then it's going to set values for subarrays for that input collection. It's going to set a left and right value because a merge sort will actually, when it gets down recursively to the bottom, to the atomic piece of that collection, of that array, it will then start comparing those pieces and kind of zipping them back together. And so when that happens, it'll need a left and a right subarray to compare against one another, and it's comparing the first item in each of those subarrays and zipping those or moving those items in that subarray into a new sorted array. Okay, so again, it's creating a left and right, and this is only happening if the collection is larger than 1. And so it will create a merge sort on the collection from 0 to the midpoint for the left-hand side, and a collection from the midpoint to the end of the array for the right-hand side, and that's that -1 index there. Okay, and then it's going to, once it finishes sorting all of these collections, then it's going to actually start merging these collections via the left and right. And I built a helper method to actually make that happen. Okay, so the merge method is going to take the left and the right side, and it's going to create an empty sorted array. And again, this is the array that will come out after those left and right sides have been merged. And then it's while the left and right side, and then it's checking to see if they are none. And if it's not none, then it's until it's empty, it's going to take the first item, and that's the index 0 of the left, and compare it against the first item, index 0 on the right. If the left item is smaller than the right item or less than the right item, it will push that into the sorted array. If the right side is smaller, it will push the right side into the sorted array. And then it'll keep going through each of those arrays and comparing. Once the left and right are empty, then it's going to add the left and right to that sorted array. So what that basically means is that if the right side is empty, the left side is already sorted. So if the right side's empty, it's going to add the left to there, and there's nothing to add for the right. But it's going to do that anyway, just to make sure that if the left is empty and the right has 1 or 2 items left in it, then it's going to just add those in, which will give us then the new sorted array. And that's what it returns with this merge sort. Okay, so let's go ahead and see what it does. Now, in order to facilitate this, I've built a shuffled array, and then again, this is just a new array that contains 10 items, and those 10 items are going to be random numbers between the numbers -100 and 100. Okay, and the first output we're going to see is actually that random array that's been created. So let's go ahead and make this console a little bit bigger so we can actually see what happens here. All right, and then we'll just go ahead and run the file. Okay, so as you can see, our random array of 10 items is -20, 24, -17, -72, 58, -98, 48, 10, 59, and 10. And yes, it will work even with repeated numbers as well. Okay, and so it's printed that, and then that first collection item has been displayed in our methods. Now, if we remember, that method return collection, unless collection size is greater than 1. If it's not greater than 1, if the size is 1, then what's going to happen then is it's going to take the midpoint of that array, and it's going to do this recursively basically until it has one element in it. So let's actually see where that happened. So you can see now that it takes 5 elements, and this is the left side. Notice 20, negative 20, 24, negative 17, 72, or negative 72, and 58. And then it's just going to keep dividing that by 2 until that array size is 1 element. Okay, so as you can see, it takes the left-hand side of this first subarray, and then it actually takes the left-hand side of this next subarray. That leaves with 1 item, and then it prints, or it shows us the other item as well. Okay, then it does the same thing with the right-hand side, all down to 1 item. Okay, and then it does the right-hand side of the original collection, and once that's done, it's going to actually start rebuilding the array. And so this actually showed us that each of those items was broken down to 1. Okay, now we can actually see what happens here if we print the sorted array. So these numbers are going to change, obviously, because they are random numbers. Unless, of course, should be able to just do this, and it will show us the exact same numbers as last time. So let's go ahead and clear the screen one more time. As you can see, it's those same numbers, and then we have our atomic units, but we also see that it's starting to build up those units. So it's broken them down, and then it's resorted that it's merged and sorted those 2 atomic units. Then it's going to break down the atomic units, and then it's going to remerge and sort them. And so here are 2 sub arrays, and then the merge to the left-hand side is negative 72, negative 20, negative 17, 24, and 58. And so that is this half that has been resorted. Then it's going to do the exact same thing with the right-hand side. It's going to break it down into atomic units, so 1 item, and then it's going to start building it back up. So you see it starts building up the left and right-hand sides of this, and then it builds up the entire left-hand side from negative 98, 10, 10, 48, and 59. And so now we have these 2 sorted subarrays, and then it's going to go ahead and recursively do that method one more time, and it's going to merge those 2 original subarrays into this one larger new subarray, and all those new arrays and will be completely sorted. So negative 98, negative 72, negative 20, negative 17, 10, 10, 24, 48, 58, and 59. So as you can see, it returns the sorted array in sorted order. And that's basically what a merge sort does. It breaks it all the way down into atomic units, into one individual unit, and it starts building that array back up from the original subarrays, but in sorted order this time. And then it builds each of those left and right hand sides up into one new subarray, and then it takes the previous left and right sides and builds those back up, all the way up to the original length of the original array. And when it returns that original array, it's zipped back up with those merged units into sorted order. All right, again, that was merge sort, and if you have any questions or comments, please put them into the forum, and I will gladly answer those as soon as possible. Thank you.